So yesterday we were talking about the services and we discussed about cluster IP service, and today we'll see how to configure NodePort IP and load balancer. These are the two remaining services. Okay, so now before discussing about configuring NodePort, first we'll discuss the difference between cluster IP and the NodePort. So as we discussed yesterday, cluster IP is for internal communication. So this service we will create to access it from the different applications. So this is one scenario, like your databases are having multiple uh, pods, and this database, if you want to connect from the another application, then these three pods might be created in three different worker nodes. So each pod is having individual IP. So instead of giving this individual IP, you need to create a cluster IP service for this specific pods deployment, so that this cluster IP and not IP. Okay, internally we will give the name. Okay, service discovery name we will give. So whatever we created yesterday, what are the name we provided to that name we are going to give inside the application. Let me log into the master. So here yesterday kubectl get svc-n nginx-dev. In this namespace we deployed the application and created the service, right? This is the name will be given inside the remaining application. Maybe if this application want to connect to this database, so if we provided this service name as an my-service, then this name has been provided inside this application. Okay, so applications will have properties file where it contains all the properties related stuff. Maybe this is connected to the database inside the cluster, or maybe your database is outside the cluster. Okay, so this kind of information will be in the application properties file. So there it will be mentioned, okay, database equal to this IP, so that it will go and access this. Okay, apart from database, it can be another service also, like as I said, we took example, let's say 15 microservices to run our application. So now these are the worker nodes, and assume, see, all the microservices whatever has been deployed has been created as an service. Okay, so this is a service. Assume only single replica, and this is app 1, and this is app 2, and this is app 3. Now for this we created some service like NodePort or load balancer, because these all are need to be accessed from the external world, not internally. So obviously we'll configure either NodePort or load balancer. Now sometimes some microservices doesn't need access from the external world. Some microservices need communication between them. Maybe this microservice is dependent on this microservice, or might be this might be dependent on this one. Means it, whenever this microservice is started, so it should able to access this microservice for communication to some generate some data, internet, some logic will be there. It doesn't require any external access. Means it doesn't mean that 15 microservices will be there, all 15 should be need to be accessed from the external world. Sometimes some microservices doesn't require accessing from the external world. So internally it is communicating with another microservice. So in this scenario, we'll create a cluster IP. Means if this microservice doesn't need access from the external world, then for this it will provide the service type will be cluster IP because it's not required externally. So if this microservice want to access this one, then what are the cluster IP service name we have provided to this service? Let's say we mention my service. So this name will be provided inside the properties file of this application. So whenever this application starts, so it will go and access this application. If it communicates, then this application will come online. If due to any reason it cannot able to reach this microservice or app, then this application will not come online. Not only on this one, maybe it contains external database. Database is outside, not in the cluster. Maybe it's a PaaS service. Assume this is a in the cloud PaaS, or maybe it's on premises. Okay, it can be anything. So if this microservice is dependent on, it should connect to this database and it should connect to this service. So if any of this database or this service is not connecting, then this application will not come online. Okay, so as an administrator, Kubernetes administrator, we need to log in and we need to see where we need to check the logs of that application, where exactly it is getting stuck. We'll see errors, right? Maybe database passwords are wrong, database URL is wrong, maybe port cannot able to reach, okay, or maybe it's cannot able to uh, connect to this service from here to here. So these things we need to check and we need to resolve that, and again if the application again redeployed when the application is started, so it will be online only when what are the dependencies are defined inside this application. If it connects to them, then only it will come online. Okay, so in this scenario we'll configure cluster IP for services. Means it no need to access from the external world, so then it will configure cluster IP, and internally this microservice will be used by some other apps, some other microservices or some other applications. So they will use this name inside their application. And if this needs to be accessed from the external world, then this we can configure as a NodePort or load balancer. So this is another real-time scenario. So instead of taking this scenario, because I never configured, maybe some organizations might be configured database also inside the Kubernetes, but whatever I have experience, I always configure database as separate PaaS service. And the exact real example is cluster IP for existing microservice, which doesn't require external access. Okay, in that scenario, we'll give cluster IP. Understood, right, about cluster IP? Now we talk about
Ravi,
NodePort. Yeah,
is it like internal load balancer it acts like, right?
yes.
Okay.
So if this service, if you're maintaining this app 3, you mentioned 3 replicas, then this might be created inside 3 worker nodes. So when this name has been defined here inside this properties file, then whenever this application is connecting, it is sending the traffic to here. So it will go to this cluster IP, and this will send traffic to 3 different parts of this app 3. Okay, if you mention 3 replicas or 2 replicas, if we take 3 example, then whenever it's connecting, it will connect to this name, my service. It's a we call it a service discovery DNS name. So with this name, it will connect this IP, and it will route the traffic equally to this 3 pods. Okay, so this is called as a, it will do load balancing. So equally it will send the traffic to these 3 pods. So if any of the pod goes wrong, then right, if you are mentioning 3 replicas, then it's replication controller or replica set responsibility to maintain 3. Then immediately it will create one more, and again this cluster IP service will be sending traffic to that newly created pod. So it's going to do load balancing cluster IP, but only internally it will work. Internally it can able to access. So now we talk about NodePort. Uh,
Kevin,
yep,
service selector name and pod label name should match, right?
yes.
Okay.
Whatever your pod label name you are giving, that should be selector for the service.
Yeah, got it. Thank you.
So NodePort is an open port on every node of your cluster. Kubernetes transparently routes incoming traffic from the NodePort, even if your application is running on different node. However, a NodePort is assigned from a pool of cluster config NodePort ranges. So here, NodePort, there for this service, Kubernetes designed to use 30,000 to 32,767 port range. So externally, whenever you want to access the service, mm, so this is an example. Okay, so if you take this example, this is how it looks like NodePort. So this is also for front-end application only because we configure NodePort to access your application from the external world. Cluster IP is not to access from the external world, internally only. But if you want to access your application from the external world, we need to configure service type called NodePort. So for this NodePort, they designed this port range 30,000 to 32,767. Means internally in your microservice or application, if the developers has written 80 or 8080, what are the port number they decided, externally you cannot access with the same port. So you should route map that port to the node port range 30,000 to 32,767. Among this, any port number you can choose it. Okay, so this is front end like pod, and application developers has been given 80 port number for that, and so that this is the target port we call it as, and same will be mapped to this port. And externally when you are accessing it, so this is two types. If you want to decide any port number from this range, then you can manually enter in the configuration file static, or else dynamically it will assign port from this range 30,000 to 32,767. It's up to us whether you want dedicated static port you want to decide in the file. So this is, if you are selecting one pod, the replica is equal to 1 means it will be deployed in one node. So the node IP will be there, right? This virtual machine IP, what are the virtual machine you have, the worker node, that IP, and this is a virtual machine IP 192.168.1.1, and whatever the port we decided 31,000, with that we need to able to access. So here multiple instances in same node. So if you are giving one replica, then it's okay. Then it will be created on one uh, virtual machine. It means in one worker node, and we can able to access. If you're mentioning replicas, but you have only one worker node, then same. This is the IP address of that machine, but all the three pods are running in the same machine. So from this IP, you can able to access that application, and internally it will send the traffic to all the three pods. But what is the purpose of having three replicas? There is no advantage, right? If this virtual machine goes down, then all these pods will be closed. So we cannot able to access the application. So application should be deployed on multiple worker nodes. Okay. So if your application is deployed on multiple worker nodes, but you cannot able to access with a single IP of all the three, pods. So pod 1, pod 2, pod 3 has been created, 3 replicas has been created. But to access the application, you need to use the 3 machines IPs, 3 worker nodes IPs this way. But do you think that this way, can you give it to your customer to access the application? You cannot give in this way, right? 3 IPs to access, and it will be difficult for the high availability also. So that's why NodePort is not preferable for the production environment. NodePort is only helpful when you are having single node, you are deploying only single pod. For that it is okay. But multiple nodes, you are deploying multiple pods, then NodePort is not suitable for that. Okay. So now we'll deploy an application and we'll see how to configure this NodePort also. Most of the practicals, see, the next topic which we are going to talk about, load balancer. The load balancer we cannot configure in all the environments. Like uh, why we choose NodePort for practical purpose, for us, for our education purpose, practical purpose, mostly we use NodePorts only. Why? Because if you are not using GKE or AKS or EKS, when you configure load balancer service after this, which we are going to talk, it is going to generate a load balancer public IP, which is chargeable, that we can able to access. But the concept like KubeADM, COPS, or on your OpenShift if you are using. So this kind of scenarios, so load balancer cannot generate a public IP and you cannot access your application. So when you are practicing any topic in your environment, in your local environment or maybe in a KubeADM environment, so at that time for that application, if you want to access, we'll configure NodePort because we are not expecting any high availability or real-time traffic. We are practicing for our knowledge purpose. Okay, maybe in future you, apart from the topics what we are discussing in this course, maybe lot of other topics might be there. So those topics to implement, you might need some service to access that application, whatever you are trying to achieve to from the external world. So we may configure, for example, let's take a, you can configure Jenkins master and slave concept inside the Kubernetes only. Means master will be also inside the as a pod will be deployed, and the slave also can be configured as a pod. That is possible. So if you are practicing this scenario, your Jenkins should be accessed from the master should be accessed from the external world. So for that purpose, what you are going to configure NodePort, because if you are using KubeADM concept, or maybe if you are using LXC containers, or if you are using Vagrant environment, then the topic which I'm going to tell in the next one, the load balancer, cannot generate the public IP. So you cannot able to access. So that's why for practical purpose, for our knowledge based, we'll use NodePort. In real time, for your organization, if it is a GKE, AKS, or maybe EKS, in this cloud environments, Kubernetes as a service, it will create a public IP and company will take care of that, the charges of that public IP. But for us, and the load balancer also chargeable. Okay, the traffic whatever is going to come in the real time, it will be chargeable. So for our practical knowledge, we'll use this NodePort. But in real time, we don't use NodePort as a service to get the real traffic in the production environment. Okay, so now I'm going to create this one deploy one application, and that application I'll configure service and will access that application from the external world. Okay, let me, I copied these diagrams from some outside external source. Okay, because instead of drawing all these things, if you get ready-mades, and that's the reason I downloaded from the internet itself. So now kubectl. This is a deployment file is there, right? So previously we used the same deployment file to deploy this application, which we used it for the cluster service, cluster IP service. Now what I'll do, I'll delete this deployment. Let me check the name of the deployment. Deployment -n nginx-dev kubectl delete deployment -n nginx-dev. See, you don't need to delete. You can just go and modify the file and give different selector name, and you can deploy. So 3 more or 2 more pods are going to be created. Okay. So nothing has been available. So now I'll go to this file, and what I'll do here, the labels name I'm going to give as an nginx-app, and here also I'll define. See, this label name and this label name no need to be same, but whatever the label name you are giving here, this should be the same with the service label name. Okay. Now I need to have a NodePort service YAML file. So let me copy that. So you guys can use this my GitHub account for YAML files, whatever I'm using as an example. So you can use that. So in this scenario for NodePort also, I'm using the same YAML file for you. For your reference, I'll show you what is that name of that YAML file. So I'm using this nginx deployment. You can take this as a reference. Okay. So this one, and here you can see the label name nginx-app. Even the same thing I've changed. You can give any label name. It's not mandatory to have nginx-app. It can be anything. Now all of this file is available inside my machine. So now I need to copy the service. Nginx-service is a NodePort service. So here how it will be decided, type equal to NodePort is there. If type equal to load balancer, then this service is a load balancer, and kind is a service. So this is one of the object or resource inside the Kubernetes cluster, and this is the name we are giving. So I will change the name because already there is a service with this name, the cluster IP service. So again, I should not use the same one. And here if you see NodePort 3007, so 30,007. Manually I'm giving this. If you don't give this line here, then randomly it will pick a port from the 30,000 to 32,767, and this is application port which is configured inside that. Okay, so basically nginx by default runs on 80 only, that's why we are using 80. If the application is using 8080 and in the service if you are using 80, then it will not work. So Why here it is 80? Because we are testing with Nginx application, which is by default uses 80 port number. In real time, if your application, Java application or Node.js application, okay, if it is taking any different port number they are using inside the microservice, that port number you need to mention here, okay, and that will be mapped to this port, whatever the node port you are giving. So this is a label name. Selector means, so whatever the label name has been provided for an application, that is the name, and this label name is for your service. Okay, so for this service we are giving some labels. So as I said, if you have lot of services, if you want to filter the services based upon the prod service or dev services or based on the application service, means hundreds of applications are there. I want to view the services related to so and so applications. Then we are giving label name to your services. So this name we can give in that way. So don't confuse that if you are giving this name here, the same name should be also here. This label name is for your service to identify, and this label name, this selector, this is not a label name, they are selector. So it will go and talk with the application which is having label name with this one and it will communicate. So now I'll copy this and I'll create a directory called services. So I'll go inside these services and then I'll NodePort.yaml file just to easily recognize giving this file. And so here important thing is I need to change the name. Node service test. This is the name I'm giving and type is NodePort and this is a selector. Okay. So now kubectl get pods -n nginx-dev in the namespace, nothing is there. So kubectl, first of all, let me check the, let me come out of this directory and open this file. This is the file I'm using. So namespace has been given here and this is a deployment and this is an app. So here also we need to give. Now kubectl create -f the file name. Now kubectl get pods -n nginx-dev in this namespace. 3 pods has been created. Now I should go inside this directory and I need to create the service to access this application from the external world. So kubectl create -f nodeport.yaml file. But sorry, I did a mistake because I did not mention the namespace inside this YAML file. So it gets created inside the here. Here it got created default namespace. So what I'll do, kubectl delete -f the same nodeport file and we can give. See, two ways you can delete. So kubectl delete svc and this name, the object name, resource name you can give, it will be deleted. Another way is kubectl delete -f, like how you created, same way you can delete. So the advantage is this one. Why? Because see, in single file, always not mandatory to mention only single resource only. In real time, you will come to know slowly. In a single file, there will be many resources might be defined. Maybe service and deployment also, both things you can define in a single file itself. Like that, 10 objects you can define in a single file. So that if you mention kubectl create -f and the YAML file, it will create all the 10 objects which you mentioned inside the file. Sequentially, it will going to create. So if 10 objects you defined and you did a mistake, means you want to recreate it. So if you are deleting with each resource, kubectl delete, for example, deployment and deployment name. Okay, this will delete the deployment. One object has been deleted, and next one you want to delete SVC, and this will be deleted. And next you created config maps might be created. This will be deleted. So instead of deleting this each and every object, if you just again use delete-f, the YAML file, then whatever was created, everything gets deleted. You no need to delete each and every object manually separately. Okay, so this way you can delete. As of now, only one object got created, so I can use anything, either this option or kubectl delete the object name SVC, and the object name also will work. But I always recommend, if you are creating anything from the file, then always try to use delete from that file itself. So it gets deleted, and I'll modify this, and I need to define namespace. Under the metadata, we need to give namespace nginx-dev, so that it will get created. Now again, let me create this one. So kubectl get svc-n nginx-dev. So the service has been created in the 5 seconds ago, and kubectl get svc-n nginx-dev. So let me describe this to see the endpoints has been created or not. Kubectl describe svc-n nginx-dev. See, endpoints has been created. Okay, and if you see 30,007 port number has been allocated to it. Now this is type is called NodePort, and even you can access this application with this IP also. This is called NodePort IP. See, if the service and this name we are going to access externally, we cannot access with that name, but internally also you can give this name to access by some other application. Maybe here we suppose we configured NodePort to access it from the external world, but this app also dependency for this app, then here we need to provide NodePort service name, whatever the service name we have provided. So let's say if this is the service name, then this service name should be provided here inside this application. So this will go and communicate to this application, and will do the functionality whatever it is expecting, the purpose of communicating. It will go and communicate. So the request will go to the service, and this service will route the traffic to this pod. Okay, so how it is communicating? So the name we are giving here, but DNS, it's like a DNS. So the IP will be for this node port. This is an IP internally, that inside the Kubernetes cluster, this node ports are having this IP. So this IP, even though it is changing in future, doesn't matter, because always we are preferring with the DNS name. This is the name we are adding inside the properties file of this application. So when this application is starting up, it will check with this service, and if it is reachable, then it will go here, and this service responsibility should send the traffic to the product. Okay, so you can test it with this one. So internally from the cluster, I am testing it. So I can able to access. This is a welcome to Nginx page. It is opening, means what? I can able to access it. So now our intention to configure this node port is to access it from the external world. So what we can do, we need to take the IP of the node, and we need to access it. So as of now, the AWS machines which I created, it's having two IPs. One is public IP and private IP. In your organization, obviously, you will be inside that private network. So you will take the private IP of your worker node. So this private IP, and you will access it in your organization, because we will be your laptop or desktop network, whatever is assigned, it will be with your cloud environment network only. You will be in the VPN, so directly we can able to access it. But for now, practical, we cannot able to access this private network from my laptop through external world. Either I need to enable VPN service so that I can able to access to this private IP. So we have another option called this one. This is only for practical, okay, for our knowledge sharing only. In real time, you don't have these IPs. You'll have only these private IPs to your virtual machines for your the clusters, means worker nodes, whatever you have, those worker node IPs will be there. So you need to access with that IP if you configure service with the NodePort. So I'm not using this one. I cannot able to access. So I'm using this public IP of this worker node to access it from the external world.
Praveen,
So here, yep.
we have three nodes, right? So
Hmm.
which IP should we use for accessing outside?
So
Like,
as of now, I mentioned three replicas. So three, we have only two worker nodes, but kubectl get pods -o wide -n nginx -dev. So it is deployed on the two machines. Okay. So here if you see on 232 machine, two pods, 118 on two pods. So if you see here, this is 232 and this is 118. It's deployed on the two machines. So you can take any of the public IP among these two, and you can able to access it. And here you need to give the port number 30,007. Then only we can able to access. And one more thing you need to keep in your mind, that we allowed all traffic inside the security groups of this AWS virtual machines. So that's why we can able to access. In real time, it will be not the same scenario. So whichever ports are required, if you are managing that security part, then you need to enable the ports, or if some other team is managing it, then you need to raise a request so that that ports will be allowed. Basically, whenever you are creating a cluster, always will give them the prerequisite to enable ports from 30,000 to 32,767 by default for the cluster. Okay, so if you create a single pod, then wherever that pod is get deployed, so you can able to access the pod of that particular worker node. Okay, as of now I mentioned three replicas, so three has been created in two worker nodes, so that's why I can able to access it here. So as I said, this is not recommended for production traffic, so we should use the type is called load balancer. Okay, so now we talk about the service called load balancer. So load balancing is see load, the name load balancer means for remaining two services also will be doing the load balancing service. Okay, cluster IP will also do the load balancing, what I've said here. uh, this way, if this name has been using by some other application, the traffic is coming here, then the cluster IP will also do the load balancing, NodePort also will do, and load balancer will also do. The usage of is different. For load balancing external traffic to pods, each with different trade-offs. So theoretically, So what load balancer will do, it will also be the same. So load balancer, when we configure for this, so what are the disadvantage in the node port, that will be resolved. So here multiple worker nodes will be there, and whatever the pods has been created, so it will be created as a service, and from external the traffic will be coming to this load balancer, and load balancer will route the traffic internally to this pods. So load balancer service is the standard way to expose a service to the internet. So this article is specifically talking about GKE. This will spin up a network load balancer that will give you a single IP address that will forward all traffic to your service. So whatever the load balancer we configure, so it will get one IP address, and all the traffic will come to that load balancer. So internally, it will route the traffic to this pods. So when would you use this? If you want to directly expose a service, this is a default method. All traffic on the port you specify will be forwarded to the service. So here, what are the port you configure for your service? Manually, we can define same like NodePort. Here also from 30,000 to 32,767, we can define a port. So what are the traffic is coming from the external? So it is going to send the traffic. So here, little bit tricky between inside the Kubedium what we configure and inside the Kubernetes as a service like GKE or maybe AKS and EKS. I never tried in EKS, so I tried with GKE and AKS. So internally, whenever you are creating a load balancer in a Kubernetes service, externally means in the cloud side also it will create one load balancer, and that will receive the traffic, and that load balancer will send your Kubernetes load balancer for this service, and it will send the traffic to this one. So whatever this load balancer is getting created, this is chargeable. Okay, but if you are creating load balancer in the Kubedium concept, means in the virtual machines you created, whether it's maybe VMware or maybe backend, it might be cloud, doesn't matter. It's a Kubedium concept. It's not a Kubernetes as a service. So it will not create any extra load balancer inside the cloud environment or maybe inside the VMware environment. But specifically inside the GKE or AKS, separate one load balancer gets created. Like I'm not sure how many of you are aware about AWS or AKS or GKE. Forget about Kubernetes. Previously, you have heard the load balancer concept in the cloud, right? The load balancer concept. In AWS also we have application load balancer, classic load balancer, network load balancer concepts are there. And even GK is also load balancer concept is there. We can create load balancing for multiple applications. That load balancer gets created when you create Kubernetes load balancer. This is one. So let me. So
So we don't want to create a load balancer externally, right?
definitely it
As
will
per
create.
my
If
knowledge.
you are creating a load balancer service in Kubernetes as a service, whether it's maybe GKE or AKS. Okay, this is the service, and type is load balancer. The type is load balancer. Then automatically in the cloud level, it will create a load balancer, and traffic will come to this load balancer. And here internal it will send this load balancer. and it will send the traffic to the pods. But if you do same concept with the KubeADM, even the virtual machines are from AKS or Azure, but if you have a worker nodes in this way and you created a service, it is not going to create any external load balancer. Okay, only this internal load balancer will be there, but this is not going to get any public IP. It will not generate any, it will show in a pending state. Okay, so again you need to access it from the NodePort IP only. That's why in the KubeADM or maybe here we cannot configure this one. So the big downside is that each service you expose with a load balancer will get its own IP address. Means here these three parts of your application you created service load balancer, this will get an IP address, and another set of service microservice. For example, you have 15 microservices. For 15 microservices, you're deciding uh, load balancers, or maybe for 10 you are deciding. Remaining all are cluster IPs. So for 10, you are going to get a 10 IPs. Each load balancer is going to get a 10 IPs, and you have to pay for load balancer per expose service. And this you have to pay line will apply only if you are creating this load balancer inside the AKS or GKS, because external load balancer also gets created. Okay, so to avoid that, and this means there is no filtering, no routing, etc. This means you can send almost any kind of traffic to it, like HTTP traffic, TCP traffic, UDP traffic. So in the load balancer, you cannot configure the traffic rules, okay, routings. So for that, ingress controller will comes into the picture. We have a separate session for that. Okay, first of all, you guys need to understand these services into practice. In the later on sessions, okay, I'm going to discuss about the ingress controller. So ingress, in this you can configure the routing, everything. Okay, how to get the traffic, whether it's HTTP traffic, TCP traffic, all the things will be configured inside the ingress. Okay, so ingress will be something like this, and these are your services. Maybe this is load balancer 1, load balancer 2, load balancer 3, and this app 1, app 2, app 3, and this ingress controller you can configure in this way. You can route the traffic. Okay, so now we'll see how to configure the load balancer. So if you can see nginx-service-lb, this you can see, and type is load balancer, and port I define 31,000. Okay, and name I need to change it again, and I need to give the namespace details. And before this, I need to delete the existing deployment, or you can maintain that. You need to change all the names. So instead of that, I'll delete it. So kubectl get deployments -n nginx-dev. So kubectl delete deployment nginx-dev kubectl get pods-n nginx-dev. Okay, I did not give the namespace -n nginx-dev. kubectl get pods-n nginx-dev. So we are doing this on specific namespace. I hope everyone understood namespace. So now again I am going to use the same file, that deployment file, and this time I'm going to change the label name. So here I'll give -lb extra, I'll add it. -lb, and let me deploy this kubectl create -a created kubectl get pods -n nginx-dev got created. Now I will copy this YAML file for load balancer service, and I'll go to the service directory, and here I will lb.yaml. This is the name I'm giving, and I need to change the name first of all. So here my service lb I'm giving because already my service is there. So here selector, I think I gave lb. This is the name I'm giving, and internal application is 80 port number, and externally we want to access it from the 31,000. Okay, the type is load balancer. Now save it, and before that, one thing I forgot to mention, namespace. So this is the namespace, and now I'm going to create it. Got created kubectl get svc-n nginx-dev. Now third one is also got created, and if you see here, it shows in a pending state. It will not allocate external IP. So if you see kubectl describe svc -n nginx hyphen, okay, so these are the endpoints, but this IP will not show, it will not allocate. But if you create it in the GKE or AKS, it will get created. Okay, if tomorrow, if time permits, I will show you in the GKE the same cluster if we create, how it will get the IP address and how we can able to access. So always remember, whenever you create this service for specific applications, make sure the endpoints is configured properly based upon the selectors. So sometimes, as I said yesterday, we do mistake while giving the labels names or selectors, so that it cannot pointing or mounting or mapping to that respective application. Two different objects will be created, but there will no be intercommunication between them if you do any single mistake inside the selector. Okay, so now, so how to access it from the external world? We can try it with the node port, like node IP. What is the port number? 31000. Okay, so we can able to access it, but with the node port IP. Even though you configure load balancer doesn't have any IP. So here one more disadvantage is, if you are using node port, if the node port IP is changed also, there is a drawback, right? Again, you will get a new IP. But load balancer, when you configure, whatever the IP you configured, that will be for the load balancer IP. So this way we can configure different services. So tomorrow I will show you the same load balancer to configure inside the GKE cluster. And then tomorrow we'll talk about different components like config maps, secrets, okay, node selectors. These are the topics we are going to discuss. Any doubts in today's session, please ask me, or else we'll wind up for today's class.
Ingress also we are discussing tomorrow, right? Ingress.
Not tomorrow, that will be later on, or once everyone is familiar with these services topics, because all together if you're talking on the same time, then people might not understand, because some might not from the networking background, or some might not from DevOps completely. So everyone is familiar with these services. If everyone practice, in the later on sessions, I will explain about that Nginx Ingress controller.
Okay.
Okay. So
Uh,
guys,
Hi,
please do
Praveen.
practice, and lot of things you need to do R&D. I'll give one example scenario. So I'm telling you the selector, the deployment. So you need to try that and tell me in the WhatsApp group. So I'm going to do 2 deployments. Okay. So for 2 deployments, I want to give Nginx-app. Is it going to work? And if I create a service with selector, if really works with 2 names, 2 deployments with same label names, when I'm creating a service with Nginx-app, then for which deployment it is mapping, you need to tell me that. Okay, then how it will take? If 2 deployments are there, 2 different microservices or 2 different applications having same label name. And when you create a service, the service is recognizing with the label name. Then if 2 deployments is having same names, then how it is going to point? So that you need to do R&D. Like this. So once you complete the basic things what we are discussing in the class, then you can do R&D stuff. Okay. So today you need to do this lab and ping me in the WhatsApp group which we have. Okay. Then we'll discuss over there. Yes, someone is asking. Can please go ahead.
Hi, Praveen. Actually, yesterday I will created a cluster IP. I'm not able to see
Mhm.
the endpoints like a
It's
pods
very
container
simple.
type.
As I said, the two, maybe the selector is wrong. So you ping me the deployment.yaml file what you used, and show me the selector what you are using there, and show me the selector in service.yaml. If the selector is not matching, then your service cannot recognize the proper application, and then it will not point to that application pods. So
Okay,
if you're
Praveen.
not able to see endpoints, that means it's not pointed to that application. Why it's not pointed? Maybe selector is not correct. Maybe it's mismatch.
Okay, I will ping you on our WhatsApp.
Yep.
Yeah, thank you.
Praveen?
Yeah.
Yeah, each namespace is isolated with each other, right?
Yes.
Can we make a connection between the namespaces like VPC peering concept in AWS?
See here, namespace, when you are using namespace, let's say, uh, that is what I was telling, like once you explore the basic things, then I can give you some tasks. Like for example, this is namespace 1, and this is namespace 2. Okay. I'm creating a service here. Let's say load balancer service. So this service, you can point it to this deployment here, whatever you do deployment. So this service can also, you can use it here. It's not like, for example, this service you cannot use for this deployment. So service can able to use it. So some not, let me confirm, config maps, secrets, service. Yep, I think service can be used. Okay, if time permits, just do an R&D. Deploy the application in different namespace. Deploy the load balancer in different namespace, and give the label names. Okay, so I think mostly it will connect to that. But config maps, secrets, image pull secrets will not work. Okay, means config map you created in this namespace, and this config map you are giving the application deployment in a different namespace will not work. Secrets will not work. Okay, I think service will work. You just try it. Okay.
Yeah, yeah. Thank you.